All right, let's talk about summer. We all think we've got to figure it out, right? Long days, warm weather, lots of sunshine. But what if I told you that about 50 miles straight up, summer is actually the coldest, iciest, and most chaotic time of the year? Yeah, we're going to dive into the really strange and fascinating world of summer way, way above the clouds. So when you hear the word summer, what's the first thing that pops into your head? For most of us, it's pretty simple, right? It's the warmest season, time for a break, get outside. It's just a predictable part of the year. But here's the thing, that's only our perspective down here on the ground. Well, get ready because this is going to flip that whole idea on its head. While we're down here enjoying the heat, the mesosphere, that's a layer of our atmosphere about 50 to 100 kilometers up, is going through extreme cold. I mean, it gets so cold that water vapor literally freezes into these shimmering ice clouds. And forget about gentle summer breezes. Up there, the season is defined by these massive, hemisphere-spanning wind reversals. It's truly a tale of two completely different summers, happening on the very same planet. Okay, so if you can't use temperature to tell what season it is, how in the world do scientists know when it's summer way up there? I mean, they can't just check the calendar. Nope. They have to become something like atmospheric detectives, decoding the winds to figure it all out. And the biggest clue they're following is something called the zonal wind. Now, this is just the big, large-scale wind that's always flowing either east or west around the planet. The best way to think about it is like the atmosphere's main highway. And the direction of the traffic on that highway, well, that's the key indicator of the season. So during the winter up there, things are pretty straightforward. The zonal winds are strong, and they're consistently blowing from the west to the east. See that eastward flow? That means it's winter. But here's the main event. The start of summer is marked by this huge, dramatic reversal. The entire system just flips, and the winds start blowing from east to west instead. When scientists see that switch happen, that's it. They know summer has officially kicked off in the mesosphere. But, this is where the puzzle really starts. To figure out if this weird summer is changing over time, scientists needed a really precise way to measure how long it lasts. And well, it turns out they came up with two different definitions. It's kind of like they're using two different yardsticks to measure the very same season. So here are the two definitions. The first one is called MLTSL. This one measures the start and end of summer at different altitudes. Think of it like starting a stopwatch way up at 96 kilometers and then stopping it lower down at 82 kilometers. The second one, M-scale-SL, is a lot more direct. It measures the start and the end at the exact same altitude. So the big question is, are these two different yardsticks going to give us the same answer? And this wasn't just a thought experiment, by the way. Researchers used more than a decade of actual real-world data, from 2004 all the way to 2020. They were using these super powerful tools called specular meteor radars in places like Germany and northern Norway to track these high-altitude winds. This gave them an incredibly detailed record from both the middle and the high latitudes of the planet. So, what did all that data end up showing? With two different ways to measure, you'd hope for a nice, clear answer, but nope. Instead, the results were totally conflicting. The two methods told completely different stories about whether the season was changing at all. And this, right here, is where it gets really, really interesting. And here's the cool finding, and this is a direct quote from the study. The MSL exhibits an increasing trend over the years, while MLTSL does not have a well-defined trend. So, one method says summers are getting longer, and the other says there's no clear trend. So which one is it? Let's break that down. According to that first definition, the MSL, summer up there in places like Germany, is getting longer by more than half a day, every single year. I mean, you add that up over the course of the whole study, and that is a really significant measurable change. But then you switch to the other yardstick, the MLTSL definition, and that trend just vanishes. It shows no significant change. Nothing. Zero. It's a real head-scratcher for scientists. How can the exact same season be getting longer and not changing at all at the very same time? So the verdict is pretty clear. How you decide to define and measure this season completely changes what you find. But it gets even more interesting. The researchers found that the biggest thing that changes from year to year isn't when summer ends. That's actually pretty stable. It's all about when summer begins. that start date is all over the place, and it seems to be heavily influenced by whatever chaotic stuff was happening in the polar vortex the winter before. And look, this isn't just some weird atmospheric trivia. This research ties directly into the much bigger picture of climate science. If we can understand why and how seasons are shifting 50 miles up, it gives us clues about the stability of our entire atmospheric system, from right here on the ground all the way to the edge of space. To try and get a clearer picture, the scientists went even further. They used a massive 31-year data set. And what they found was that the trend isn't just a simple straight line. Something seems to shift right around the year 2008. They call it a breakpoint, and it suggests that the changes aren't even consistent. They're actually changing themselves over the decades. The plot, as they say, thickens. Naturally, the next big question was, why is this happening? So scientists went looking for a cause. They checked all the usual suspects: solar activity, big climate patterns like El Nino, major warming events in the stratosphere, you name it. And the result? They couldn't find a single clear connection. There's no obvious driver, which really just goes to show how incredibly complex and interconnected our planet's climate system is. So, in the end, the mystery isn't completely solved. But this whole investigation reveals something pretty profound. The very idea of a season is changing, way up high above the clouds. And that leaves us with one last big question to think about. If something as fundamental as a season is changing in such a remote part of our atmosphere, what other hidden, interconnected changes are happening to our world right now, just out of our view?